the Earth Science final review session for you seniors only. Normally we do this with Mr. Mosel and I, but I think it's just going to be me today unless I run out of time and hand it over. So I'm going to take you through your whole review sheet, page by page, number by number, and get you ready for your exams. All right, guys, so we are going to start with number 1 and number 2 together, asking about mass wasting, what triggers affect it, and examples for each. So the first example is oversteepened slopes. When you have an oversteepened slope, the angle is just too high, and so rocks are prone to falling. So the example of slope is falling rocks. The second example for number 1 and 2 is oversaturated soil. If you have land that is way too wet, it's going to be prone to flooding and then prone to mudslides or landslides. The third example is removal of vegetation. So if you pull all of the plants out of an area, you remove the roots. If you remove the roots, there's nothing to hold the soil down, and you end up with dust storms and things like the Dust Bowl. The fourth example is earthquakes. How do earthquakes affect mass movements? They can cause a lot of land to go careening down a hill because everything is unsettled. On this slide, you have the rock cycle. Here you have the rock cycle. So in your question, you're supposed to label all of the arrows. So please notice that we have all the different arrows labeled here, and you need to know how each works. So if I ask you, what happens if a metamorphic rock is melted, you would say it turns into magma. What happens if magma is cooled? It turns into igneous rock, and so on and so forth. So take a few minutes, go ahead and get all these correct. All right, on this slide, this is for number 4, what occurs during stream sorting. So as a stream flows across, the sediments that are in that stream are going to separate out by mass, and then they'll be deposited by mass. So the heaviest ones are going to be deposited first, and the lightest ones are going to be deposited last. And then the next question asked, what is stream capacity? That is number 7. Stream capacity is the amount of something that the stream can carry. So it's determined by the amount of energy the stream has. A fast stream is going to be able to carry a lot more stuff, so it has a higher capacity. All right, here we have questions 8, 9, and 10. The types of weathering, so there's 3 types. Mechanical, that is a physical change. Chemical, that is a molecular change. It only occurs on the surface of a rock because it can only occur where the rock is exposed to weathering agents. The third is biological weathering. So you get the bio prefix. That means it's caused by living things. So plants or animals have caused that weathering to happen. So maybe if you have plants, you have roots that have grown down into a rock and caused the rock to break. Or say you have an animal that has burrowed down and it's actually carving out the rocks with its hands. On the next page, you're going to tell whether each picture is M for mechanical, C for chemical, or B for biological. So here are your 4 practice pictures. It's not on your review sheet, but I did think you needed some time to practice these. Looking at the first picture, you have a plant that is grown down into a rock. So that is biological. In your second picture, you have a big old, which one are we looking at here? I think we have the rust. Yes, that is chemical change. So then you also have a statue, and that's been worn away. It's on the surface, so it's a chemical change. And then the last one is a pothole, and that is mechanical because it's been caused by water seeping down into the cracks and freezing, expanding, breaking the asphalt. Okay, so for number 11, it says, what events occur when water expands within a rock, and when does that happen? So I wrote down it happens at night because it's cold, and that's because water becomes 9% larger when it is frozen. So if you put a bottle of water in the freezer overnight, the bottle will actually be deformed because the water has gotten larger. So for number 12, it asks about what happens when water contracts within a rock. So this happens during daytime when the water is warmer, and so the water shrinks, it gets smaller. It might even get warm enough to evaporate, so that water can then go away. So what is caused by the expansion of water within rock that causes potholes, rocks to break, etc. Water contracting wouldn't cause anything to the rocks. It would just evaporate. So if you turn your paper to the back, you have a nice little chart with 5 different terms about weathering that you're going to define and tell whether they are mechanical, chemical, or biological. The first one is solution weathering. This is when a solution, such as perhaps acid rain, damages the surface of a rock. So it's a regular rock, but the rain itself is what has the chemical in it. So that's why the solution, the rain, does the weathering. So you can see it only happens on the surface. For example, we have this statue here. This statue has been worn away by acid rain. This next one is oxidation. Oxidation is another chemical change. It is when oxygen steals atoms from iron in a chemical reaction. So when oxygen steals atoms from iron, you get rust. All right, the third is root wedging. So this is when plant roots grow between the cracks in a rock and cause it to break. This one is biological. All right, it's done by plants, so it's a bio type of weathering. Frost wedging is a physical or mechanical change. So again, we've talked about this now many times. When water enters the crack in the rocks and it freezes, it expands and it breaks the rock. And so that's how potholes get formed, which is why the roads are always way worse after the winter, after the ground has had frozen water in it. So now that's why you have all these construction crews out right now going and fixing all of these potholes in the road that were caused by the cold season. Okay, I'll read through this definition for you of abrasion. Abrasion is the wearing down of rocks due to friction. Water is an example. Water transports sediments and wears rocks down, and then gravity causes those rocks to tumble downhill and wears rocks down. Another one besides water is wind. All right, so you get wind that flies past a rock, and then it carves these beautiful structures like you see here, out of the existing rock that was there. To us, it looks mysterious. How could it look this way? And that's because different parts of the rock are stronger, other parts are weaker, and so as the wind is going past it, wears down the weaker parts first, leaving these cool shapes. Okay, solubility. This is the ability of a given substance, the solute, to dissolve in a solvent. So, like the ability of salt is the solute, to dissolve in water. Water is the solvent. Water is doing this dissolving, okay? And always think of the Kool-Aid example when you think about this. So here's the Kool-Aid example. Oh, yeah. The question for 19 was, which factor, when increased, will also increase the rate of solubility? Well, you can increase the temperature of the liquid, the solvent, and that will help you increase the ability of a solute to dissolve. So, a little example. This weekend, I decided to make sweet tea. You make your tea, and then you have to add a sugary syrup. So you take water and you boil it and you add sugar to it so that all that sugar, you can oversaturate the water by heating up the water. And then you pour it into your sweet tea and it'll get mixed all in and everything will be super sugar sweet. Okay, recrystallization. It sounds like a really big word. It's a really, really simple concept. Here's how it works. First off, you have a liquid. You dissolve crystals into that liquid. And then you cool that down to evaporate the liquid and form more crystals. So another example of that is the rock candy, like you see in the picture. You pour a cup of water into a jar. You heat up the water. You add sugar until it dissolves. And then you let it dry and some of the water evaporates and the sugar becomes crystals again. Recrystallization. So with recrystallization, we needed to talk about the melting temperature of rocks. So I've put the intersection of both rocks on this temperature curve on the paper. For rock A, the intersection, I pulled it down. It's about 900 degrees Celsius. For rock B, that line hits the graph at about 2,000 degrees Celsius. So those are the melting temperatures of those two rocks. So a question is coming up. Which is a lower melting temperature? The lower one is 900 degrees Celsius. So which rock has the lowest melting point? It is rock A because it melts at 900 degrees. For rock B, we'd have to bring it all the way up to 2,000 degrees to get it to melt. So for number 23, a rock with a low melting point, it melts at a cooler temperature, is a rock that has water content, high water content. The more water, the lower the temperature of melting will be. Why? Because the water is easy to get it to melt. Okay, number 24. These are just the layers of Earth's model. The bottom layer is the inner core, followed by the outer core. And then the liquidish layer is next. That is the mantle, followed by the continental crust. And then lastly, the oceanic crust is on the left over there. All right, for this question, we're going to go ahead with number 25. Which layer of Earth is the densest? That is the core. Because it is dense, it sinks all the way to the bottom. Which layer is the least dense is the second question. That would be the continental crust. It's the one that floats. All right, so if you are the least dense, you are going to float. Which layer of Earth consists of basalt? That is the oceanic crust. So think of salt water. Basalt is in the ocean. The layer that consists of iron and nickel, that is the core. So if you've ever heard someone say, what is the center of the Earth made of? It's a ball of iron and nickel. Yes, that's true. That's the core. All right, which layer is a liquid material? It's more of a plasma, less of a liquid, but that is the mantle. So we say it's liquidish. Which layer is responsible for generating Earth's magnetic field? The magnetic field is generated by the core. You see number 31. We're going to have that on the next page. So let me pause. And here we are. So what is happening to the magnetic field over time? It is getting weaker, specifically over the poles, and that suggests to us that it is getting ready to make a flip. Will a magnetic field flip kill everything on Earth?